Hello everyone, today we're going to be working on example 6-2, and this example is asking us to determine the force in each member of the truss shown below. So the first thing that we have to do when determining the forces of each of those members is first determining the reactions. So as you guys can see, we have at point A, we have a roller. So that means that we're going to have a vertical reaction. I'm going to assume that this reaction is going upward. We're going to call it A sub y. And then from there, at point C, we have a pin support, meaning we're going to have a vertical and a horizontal reaction. I'm going to assume that this one is going to be going to the left. We're going to call this C of x. And then from there, we're going to call this, from there, for our vertical reaction, I'm going to assume that it's going downwards. And we're going to call this C of y. So now that we have that, now the next step would be determining the values of those reactions. So the first thing that I'm going to do is I'm going to take the sum of the moments of the forces in the x direction, so that way we could determine the value of our reaction C of x. So as you can see, we have here only two uh, forces in the x direction, which is the 600 newtons and the C of x. 600 newtons to the right, that means positive. We assume that that the reaction C of x is going to the left, so a negative force right there. So we know that the sum of our forces in the x direction have to equal 0. We have positive 600 newtons going to the right, and then we assumed that our reaction is going to the left, so that would make it negative, and that has to equal 0. Meaning C of x has a value of 600 newtons as well. We ended up getting a positive number. That means we assumed correctly of the direction of our reaction. So here we found one of the reactions. Now we're going to do what we're going to do to determine the values of A of y and C of y. I'm going to take the sum of the moments about point C, because that way C of x would not be creating a moment, nor would C of y, meaning I would be able to solve for A of y. Counterclockwise positive moment. We know that the sum of our moments about point C has to also equal 0. So from here we have this 400 newtons that's being applied downwards. We know that's going to be creating that counterclockwise moment, meaning a positive moment. And we know that the distance is 3 meters. So positive moment of, remember, moment is equal to the force times the distance. From there, we have our force A sub y. This one's going upwards, so that means it's going to be creating that clockwise moment, negative moment. And the distance is going to be 6 meters. So negative moment of the force, what we're trying to determine, times the distance, 6 meters. And then from there, we have one more force that's going to be creating a moment, which is the 600 newtons. This 600 newtons is going to the right. That means it's going to be creating that counterclockwise moment, meaning a positive moment. And then the distance is going to be that 4 meters. So from there, positive moment of 600 newtons times 4 meters, that has to equal 0. We solve this for A sub y. We end up getting that A sub y is equal to 600 newtons. And since we got a positive number, that means that we assumed correctly. So we do know that a sub y is going to be going upwards. And now we're going to take the sum of the forces in the y direction to be able to determine the value of c of y. So we know that a sub y is going upwards, so that means positive. We have a negative 400 newtons here, and then negative c of y, which is what we assumed. So we have positive 600 newtons minus the 400 newtons. And we assume that c of y is going to go downwards, so minus c of y has to equal 0. We end up getting that c of y is equal to 200 newtons. It came out as a positive number, meaning that we assumed correctly, so we know that's going to be going downwards. So now that we determined the values of our reactions, now we can proceed to determining the forces of each of the members of the truss that we were given. So I'm just going to quickly go ahead and put the values of each of these reactions. 600 newtons, 600 newtons, 200 newtons. So now to be able to determine the forces of each of those members, what we're going to be doing is we're going to be using the method of joints. So that's our second step. Using method of joints, I'm going to start off by doing joint C because with doing joint C, I'll be able to determine the bar BC and CD. So I'm going to start off with joint C. If we were to draw out joint C, we have our joint C. We have our C of X that we know that's going to the left with a value of 600 newtons. From there, we have our C of Y that we know that's going to be acting downwards with a value of 200 newtons. And then from there, we have our two forces of the bars. I'm going to assume that they're both in tension for right now. So I'm going to be drawing the forces going outwards since I'm assuming in tension, and we're going to call this force CD since it's the bar CD, and then this one's going to be force BC. We'll draw these actually in a different color. So now to determine the forces of each of those members, the only thing that we have to do is just take the sum of the forces in the X and Y direction to determine their values. So I'm going to start off with the sum of our forces in the Y direction have to equal 0. I assume tension for force CD, so negative force CD minus the 200 newtons has to equal 0. We end up getting that force CD is equal to negative 200 newtons. And since we got a negative number, remember you guys, when you end up getting a positive number in the end, that means that it's going to be in tension. Negative number means it's going to be in compression. So we know that's going to be in compression. Now we're going to take the sum of our forces in the Y direction. Sorry, in the X direction. We have negative 600 newtons. We assumed also that our force BC would be in tension, so negative is equal to 0. We end up getting that force BC is equal to negative 600 newtons. That means that it's also going to be in compression. So I'm just gonna quickly come over here and just check that we already found the forces of these two bars. Now, the next joint that I'm gonna be doing is I'm gonna be doing joint D, so that way I could determine the bar AD and bar BD. So joint D. From joint D, we have the 200 newtons, because remember, it's this bar right here. We determined that the bar or the force of the bar CD is in compression for 200 newtons. So that means that it's going to be going towards that joint. From there, we have our 600 newtons of that force. From there, we have our bar, which is at an angle. We're going to call this force BD. And then from there, we have another force of our bar AD. So before we go determining the force of AD, we have to determine the force of BC really quick. So what I'm going to do is I'm going to go back and look at this. Look at this triangle. As you guys could see, it's given to us that the length right here, it has a length of 3 meters. Right here has a length of 4 meters. So we know that this is a 3, 4, 5 triangle, as you guys could tell. So, sorry, 3 meters like this, 4 meters of height. So that means that this has a length of 5 meters. So we could use that to determine the force BD. So we know right here, this is a 3, 4, 5. Okay, so now I'm going to be taking the sum of the forces in the y direction. So from here we know that force BC has a force, a vertical force. So to determine that force, we're going to be multiplying force BC by 4/5 because we're trying to determine that vertical component of it. And the hypotenuse is the force that we know. So 4/5 times force BC. And then from there, our other vertical force is the 200 newtons going downwards. So minus 200 newtons has to equal 0. Sorry, force BD. So we end up getting that force BD is equal to 250 newtons. We end up getting a positive number, means that it is in tension. Now we could proceed to taking the sum of the forces in the x direction. We know that we're assuming that force AD is in tension, so negative in this case. So negative force of AD since it be going to the left. From there, we have plus the 600 newtons. And then from there, we have our force BC, which also has that horizontal component. But this time, we know the value of the force BD. So this time, we're going to be multiplying that force by 3/5, since now we're trying to find that horizontal component of it. So times, sorry, minus, we're putting minus because remember, it's slanted, it's going to the left, so that means it's going to be negative. negative 3/5 times 250 newtons. And with that, if we solve for force AD, we end up getting that it has a value of 450 newtons, positive number, so that means that once again, it's in tension. So now I'm going to go up here. We determined the value for this one too, the force and the force. So now we just have to determine the value of this bar right here. I'm going to be taking the method of joints from joint A. So now we're going to draw out joint A. So joint A is going to look something like this. We're going to have that 600 newtons coming upwards from the reaction. Then we have that 450 newtons from the force AD. Since we know that's in tension, we know that they're going to be pulling at each other, facing each other. So tension means away from that joint. And from there, we have our bar, which we're going to determine the force of AB. Remember, once again, we know that this triangle right here is a 3, 4, 5 triangle because it's given to us that this side is 3 meters long, this side is 4 meters long, so we know that this side will be 5 meters long. 3, 4, 5. Okay, so now that we know that, we can now continue. I'm going to be taking the sum of the forces in the y direction just to determine the force of AB. Or you could also take the sum of the moments of the forces, the sum of the forces in the x direction. It doesn't matter. If you guys want, I'll do it both ways just to show you guys how we would still get the same answer. So we know that the sum of our forces in the y direction have to equal 0. We have 600 newtons going upwards, so that means that they're going to be positive. From there, we could see that this bar is slanted. Since we assume that our forces, or that force in the member, is going to be in tension, we're assuming upwards, so that means positive also. But now to determine that vertical component of it, we're going to be multiplying our force AB by 4/5, since we're trying to determine that vertical component. So 4/5 times force AB equal to 0. We end up getting that force AB is equal to negative 750 newtons in compression. So that's actually going to be in compression. From there, let's say if you would have taken the sum of our forces in the x direction, what you would have done is we have 450 newtons going to the right, positive. And then once again, we assumed that this was going to be in tension. So as you guys could see, that's leaning slightly towards the right. So again, positive force. And for this one, we would be multiplying the force AB by 3/5, since this time we're trying to determine that horizontal component of it. So plus 3/5 of force AB has to equal 0. Once again, if you were to solve for this, you would end up getting that force AB is also equal to negative 750 newtons in. So since it's negative, that means it would be in compression. So now that we found all of the forces, now we could go over here and quickly on our final answer drawing, I'm just going to write out everything that we found, our reactions and everything. So here we have a reaction going downwards of 200 newtons. From there, we have a reaction of 600 newtons going to the left. And from there, the reaction of 600 newtons going upwards. From there, we found the forces of each of the bars. We know that this bar has a force of 750 newtons and it's in compression. We know that this bar has a force of 450 newtons in tension. We know that this bar has a value of 200 newtons in compression. We know that the bar BD has a value of 250 newtons in tension. And we know that bar BC has a value of 600 newtons in compression. Thank you guys so much for watching this video. Please feel free to give this video a thumbs up, and also please feel free to subscribe to our channel if you guys would like to see more videos like this.